Okay, now here's another application type problem that we can work on, and this has to deal with driving and stopping. Okay, so it says a driver coming to an intersection sees the word stop in the roadway. You've seen those before. You may have seen those before. I know I have. If you do a lot of driving, traveling around in different states too, sometimes they do that. It says, from the measurements shown in the figure, okay, so here's the measurements, so I'm going to show you the measurements. So here's the car. Okay, and here's the word stop. Let's say the word stop is right there. And let's say that's the T, right? So let's say we've got this T on the street, right? And so we've got our angle of our eyes, right? Okay, so that let's say our eyes are from right here, and so we want to find, there's that distance, but then there's right there that distance. So from the top of the T to the bottom of the T, right? Okay, and so, and again, this is a triangle, even though my artistic skill for straight lines isn't the greatest, but let's say this is a triangle, right? So now, what else do they tell us? Oh, to the bottom, to the road, right? So from the road, from here, we got this road. So in this case here, we've got from here to here, right? So we've got this right triangle. Okay, and so what do we got? We got this point E. So we've got this point at the top. And then what other points do we have? We have B, S, and T. So this is B, S, and T. Okay, so now we know we're 15 meters. Let's see, it says, let's see here. So 15 meters from the word stop. So we're 15 meters from the word stop. So this distance right here is 15.0 meters. And then the distance from my eyes to the ground is 1.5 meters. So this distance here is 1.2 meters. Okay? And the angle that I want to find is this angle. The angle of my eyes, right? From the horizontal, I want to find that angle. And so this is the information I have. All right. Now, well, so here's the thing. So here's a couple things. We know that this forms a right triangle, right? And we're trying to find angle theta here. So we can find angles using tangent. Right, because there's two right triangles here. There's the right triangle that goes from here to here, right? But then there's another right triangle that goes all the way to here. So there's two right triangles, just like in the previous example. Okay, so even though this curves a little bit, it's probably more accurate. Let me do it this way, like that. Right? So maybe it's easier to see that way. So I've got a bigger triangle and a smaller triangle. Okay? So how do they do it? So there's a couple ways that you could do it. Okay? So, in this case here, let's see here. Okay, a couple of different ways you could do this. Okay, let's do it one way. So let's say you've got these two sides, right? So you could use angle BSE, right? We could find angle TEB. Right? We could find angle TEB, so that's TEB, right? By taking the tangent of angle BET, and that's going to equal opposite, hold on a second. Oh, I think I got let me make sure this is written right. Oh, I am missing some information. Okay, and this distance here, the height of the word is 3 meters. Okay, so I knew I was missing some information. Okay, now that makes sense. So now I've got a full picture. So now what I can do is I can find angle BET, right? So the angle BET is this angle here. So BET. So this larger angle here. By taking the opposite over adjacent, which would in this case would be 18.0 over 1.2. And then if I take the inverse tangent of both sides, then I get angle BET is equal to tangent inverse of 18.0 over 1.2, which is going to give us an approximate angle of 86.2 degrees. Okay? Now what I can do is I can then take and find angle BES. So the tangent of angle BES is what? Well, the opposite of this angle, BES, is 15 over 1.2. And now if I take the inverse tangent of both sides, so I get angle BES equals inverse tangent of 15.0 divided by 1.2. And this is going to give us an approximate angle of 85.4. Okay, now, I want theta. So what's theta equal to? Well, I just found the angle BET, so the larger angle, and then I found the angle BES. So if I subtract the smaller angle from the bigger angle, then I'll get theta. So theta is angle BET minus angle BES, which equals what? 86.2 degrees minus 85.4 degrees. And so the angle of theta becomes 0.8. So 0.8 degrees. Okay, now, that's one way to do it. Now, the other way to do it is, notice that this here, let me think. Maybe there isn't another way to do it. Let me think. No, never mind. I take that back. Nope, this is the only way to do it. I was thinking about transversals again, but in this case, no. No. So this is the easiest, straightforward way to do it. Okay, that's it. Have a great day.